All right. So this stuff is not too bad. It's mostly just SOHCAHTOA. The difficult questions are going to be where they don't give you a diagram. Let's take a look at this question. All right, so we have a plane that's supposed to go straight up, but then I guess there's some wind or something that's pushing it to the left, towards the west direction. The question is, what is this angle, right? I think that's what the question is asking us. All right. How many degrees? We're looking for theta. Which part of this diagram, which sides of the triangle do we know? They've given us two numbers here. What do you think? So we start down here. Time is 0. After 1 hour, do we end up at the hypotenuse or do you end up at this point?
The other point.
Yeah, so which part of this triangle is 350? The hypotenuse, base, or the opposite, adjacent, or the hypotenuse? The opposite would be 48 because that's how far it's drifted off its course. And the fact that it's taking this path means this is 350, not the straight line there. So now we're looking for theta, sine, cos, or tan.
Sine.
Sine is right. So the answer is just sine inverse of 48 divided by 350, whatever that is, and you're done. Again, most of these are going to be easy questions. This one isn't so easy. Question. Notice how this triangle is not an isosceles triangle. Is this side length the same as this?
No.
No, so it's not 32.5. If it was, then things would be easy. So what do we do in this case? We're trying to find the height of the tree. We're given the total base and we're given two angles. You gotta turn it into two different triangles. So we're looking for, I guess you can call this H or whatever, H. I'm gonna cut this in half right here, which means both of these triangles are gonna be right-angled triangle. This distance here is going to be X. What is this distance?
65 minus X.
Right, 65 minus X. So hopefully we get the answer for this using this approach. Let's look at the right triangle. We're looking for the opposite. We don't care about the hypotenuse. We're looking for the opposite. We have the adjacent. It's going to be tan, right? Tan 30 is equals to the opposite over the adjacent. What about on the left triangle? What's the ratio? It's going to be tan 35 is equals to what? The opposite
H over
is
65 minus X.
right, so it's going to be H over 65 minus X. Now we have two different equations. We need to do a little bit of a substitution here. I'm going to solve for H. I guess you could even solve for X on both. You can't solve for X because there's a 65 minus X. Let's solve for H on both sides. So here I'm going to multiply both sides by an X. I get h is x times tan 30. On the other side, I get h is 65 minus x times tan 35. That's what we have. We know this h and this h are equal. They represent the same thing, the height of the tree. So that means this side of the equation must be equals to this side of the equation. So h is h. This h is equals to this h, which means x times tan 30 is equals to 65 minus x times tan 35. So now we have a linear equation. How do we solve this for x? What will be the next step? It's a linear equation. So there's a bracket on the right side, probably a good idea to get rid of that. So let's open that bracket. You're gonna get 65 times tan 35 minus x times tan 35. Now here we're trying to solve for x in these equations. That's one of the unknown. And if we know x, we can plug it in here, and then that will give us h. If you know x, you can plug it right here, and that'll give us the height. So we're trying to solve for x right now. It's an unknown. A good rule of thumb is to have the same variables on the same side of the equation. In other words, group up the like terms. So here our like terms is x times tan 30. Well, there's an x there, and then there's an x here. So we're going to move this to the other side. So this becomes x times tan 30 minus x times tan 35 is equals to 65 times tan 35. Now what do we do?
Wouldn't you be adding it?
You're right, we'd be adding it. Now what?
You divide by 65?
Nope. We're trying to solve for x, so we need to get rid of these guys. Can we pull something out on the left side?
X?
X. So that would be the next step. You want to pull out an x on the left. You get tan 30 plus tan 35. And this is going to be equals to 65 times tan 35. And now you want to divide both sides by the bracket on the left. So you get 65 times tan 35 all over tan 30 plus tan 35. Like that. Let's plug this in. 65 times tan 35 divided by tan 30 plus tan 35 gives me 36. X is 36. But we're not looking for x. The question's asking us for the height of the tree. So we're looking for h. What do we do now? We have x. We're looking for h. That's something to do with these.
You plug it in there?
Yeah, you can just plug it in here, or you can plug it in there. Both of them will give you the same answer. So I'm just going to do 36 times tan 30. And that gives me the height of the tree as 21 meters to the nearest whole number. And we are done with this question. So this one is slightly trickier because it's not an isosceles triangle. If it was, then you could have cut it in half, I guess. But here you need to use this approach, which makes things a little bit more difficult. But again, it's just SOHCAHTOA. It's just tan is tan, and then you're grouping up the like terms. For the next one, there is a video camera mounted to the top of the building. So I'm assuming the camera is right here. What is the question asking? The angle of depression and the angle of elevation is given. And the question is, what is this h, the height of the taller building? This is also the question, actually, distance between the two buildings. So let's go one by one. Let's find the distance between the two buildings. Do we know the length of this side?
120.
What about this angle? Because this has to be a right angle triangle, right? This bit is right angle because it's one side of a, whatever this is, rectangle. So this is right angle. They're all right angles. So to find this angle in the middle, you just do 90 minus 36. And look at this, you do 90 minus 30, 60 minus 6, that's going to be 54. So we know this is 120, that angle is 54. We're looking for this sine, cosine, or tan.
Tan.
Tan is right. So you're going to do tan of 54 is equals to, I guess we can call that distance d, opposite over the adjacent. We don't know the hypotenuse of that triangle, so only tan is going to work. So d is going to be 120 times tan 54. And that is 165 meters. And that's the answer to part A. Part B now says, how tall is the building? What is going to be our approach here? You want to think
You
about
find the distance of like each of those triangles.
like here and here?
Yeah.
Right, because we know this down here is 165, so this up here must be 165 as well. So we can look at it like this way. This is 165, this is 47, this is 36, and this is missing. So is this a sine, cos, or tan? How do we find this side?
It's tan.
It's tan, exactly. So it's going to be tan 47 is equals to x over 165. So x is going to be 165 times tan 47, where x is like this distance here. Similarly, y will be on the other triangle. This y will be 36 and 165, so it'll be 165 times tan 36. And then you want to add x plus y after plugging it into the calculator, and that will give you the final answer of h, the height of the building. And you are done. Let's see if we can answer this one. So we have an equilateral pentagon. We know the side lengths, all of them are 8.2. Calculate the measure of theta to the nearest degree. What is our approach here? So if that's theta, we know this is theta, right? Because this is an isosceles triangle, it's going to cut it in half right there. What do we do now? Is there anything we can do? What do you think that angle is, theta? Is it 45? You gotta think about the information they've given you because as of right now, we only know the side lengths. You need two things to solve a triangle. You either need two side lengths or you need a side length and an angle for each right angle triangle, which leaves us with only one possibility, which is that theta, we must know what theta is. What is it? It's 45. And you're done from here. From here, super simple. Now that you know theta, you can find this side by just doing, what is it? You were looking for the adjacent, you know the hypotenuse, use cosines and multiply that by 2 and you're done. Let's look at this next question. Determine the acute angle. So now we're looking for the angle between two lines. First one is 2x minus 1. We know how to graph straight lines. Start at the y-intercept, and then your slope is positive 2. So 2 units rise for every 1 unit run. So this is going to be our first line. Our second line is 0.5x plus 2. So we're going to start at 2. And then 0.5 means the same thing as 1 over 2. So for every 1 unit you go up, you're going to go 2 units to the right, yeah? Rise over run.
Mhm.
Connect the dots. There we go. Those are the two lines. Now it says determine the acute angle between these two. So I'm assuming we're looking for this angle, which will be the exact same thing as this angle because they are opposite angles. Any ideas on how to do this? Let me give you a hint. So I'm looking at the blue line. Let's turn that into a triangle. From here to here for the blue line, we're looking for, well, we're not looking for that. That's not theta. I'm looking at this blue triangle here. So we know our run was 1, our rise was 1, and our run was 2. Like that, yeah?
Mhm.
Let's find this angle. Sine, cosine, or tan?
Tan.
Tan. So tan inverse of 2 opposite over adjacent. So tan inverse of 2. So that angle is 63 degrees. Like this angle is 60. This entire angle is 63 for the blue. Now we're going to do the same thing for the green. Remember, it's like this. We found this is 63. The green one goes like this. This is our theta, the angle between the blue and the green. We know this big angle is 63. If we have this small one, we can just do 63 minus the small one, and that'll give us the angle between them. So now let's look at the green. I'm going to look at it from here to here. Right there. Our run is 2 units. What's our rise? It's the rise of this triangle. It's 4. You can just count. 1, 2, 3, 4. Yeah?
Mm-hmm.
4 boxes, so 4. So let's find this angle. Again, it's going to be 10. It's going to be tan inverse of 2 divided by 4, opposite over adjacent. Whenever you're trying to find the angle, you need to do the inverse. So that is like 27 degrees. So this inside angle is 27. And then this big angle for blue was 63. We're looking for the middle angle. What do?
You subtract 27.
Exactly. You subtract 27, so it's going to be 36 degrees. And that's the angle between them. And you're done. Did that make sense?
Mm-hmm.
So if you don't have right angle triangles, you want to kind of force them to become right angle by extending it. And hopefully by subtracting some things, you'll get what you're looking for. So that was also a complicated problem. So here we're given this up here is 15, which means down here is 15. This is 10, which means this is 10. The question's asking us, what's the angle of BAC? So this angle here, to the nearest degree, the angle to the top left. Sine, cosine, or tan?
Tan.
10 is right. So you just do tan inverse of 10 over 15 and you're done. That's the entire question. 10 seconds. Not too bad. None of these are bad. Maybe this one? Let's see. So he's trying to support a tower with a guy wire, which is just like a metallic wire. So we're given the diagram. What is the length of each guy wire that Brett needs? So we're looking for this. This is the wire here. What's our approach for this question? First of all, are those two triangles similar? There's a sun somewhere here. They both have 90 degrees, and because the sun is casting a shadow, this angle must be equal to this angle. So the larger triangle and the smaller triangle, they're similar triangles. When you're dealing with a similar triangle problem, you want to find the scale factor, the K value. How do you find the K here?
9 divided by 0.6.
Yes. So that's 90 over 6, that's 15. So K value is 15. So let's find this.
You multiply that by 1.85.
So that'll be 27.75. How do we find the hypotenuse of this triangle?
You can use the Pythagorean theorem.
Yeah, you can use it, and you're pretty much done. That's the entire question. Squared plus 9 squared, and it has to be bigger. I got 29 meters, and you are done. That's the length of the wire he needs. Maybe we'll do this. It says calculate the slope of, sorry, not the slope, the length of AB using the information provided. All right, what's our approach for this one? Can we find BD right now? Can we find
Yes.
this? So that's gonna be a tan. So tan 20 is BD over 100. It's a tan because that's the opposite, and you're given the adjacent. So BD would be 100 times tan 20, which is 36.4. That's step number 1. Can we find AD?
Yes.
How do we find AD?
You use tan, and then the angle is 40.
Right, so tan 40 is AD over, still the adjacent is 100. So AD is 100 times tan 40. That is 83.9. So this big side is 83.9 AD, and then BD is only 36.4. So now how do we find AB?
You subtract 36.4.
Right, you subtract 36.4. So your final answer is 47.5. And you're done, easy. Right angle triangles are not too bad, honestly. Let's do one more. So there's a building that's 16 meters tall. The angle of elevation from here to a second building, I guess the second building is larger, has to be, is 48 degrees. Angle of elevation and depression is always from the horizontal. So that's our setup right now. The buildings are 30 meters apart. That means this is 30. What is the height of the taller building? So we're looking for this entire height. I mean, it's pretty easy. You just find this, right? And then you add 16. So to do that, that's the opposite. So tan 48 is equals to the opposite over 30. So opposite is going to be tan 48 times 30, which is 33.3. So that's just this. And then you want to add that with 16 to get a final answer of 49.3 meters for the length of the entire building. And you are done with this question. This unit is pretty simple, right?
Mm-hmm.
Just keep in mind when you have to use multiple triangles like this one. Sometimes you have to subtract things, and that's when things get slightly more difficult, like we did for this question as well. But that's as hard as it gets for SOHCAHTOA right angle triangles. All right, let's call it there.
Okay, thank you.
See ya.